Hi there. I'm Julian Erickson. This is my 3D printer that I just completed. Right now it's just working on its first print. It's just an abstract piece with some different kinds of geometry to test how well it can print it. And right now it's working on the infill of the print. And this is the entire machine here working. So while it's working on the infill, I'm going to show a little bit about how this works, and then we'll come back to watch it do the perimeter of the part, which is a little bit more fun to watch. Over here, this is where the process begins. This is a 3D model that's loaded in the Slicer software that turns the 3D model into G-code, which is instructions for the robot. I load it onto a flash drive and take it over to this old PC right here. You can watch it running the program right here. It shows the paths and the tool head right here, and this is the actual code that it's executing currently. From the computer, there's a parallel port that goes into this breakout board right there. The breakout board runs the stepper motor drivers, which actually run the stepper motors, these black things right here. And that controls 3 axes of motion. This is called a Cartesian robot. Right here I got a vice grip and the printer head mounted into the vice grip. And I got a fan over here, the cool electronics, an old PC power supply that actually powers the heat for the printer head. And the printer head is actually drawing from PLA plastic over here. And it squirts out little bits of molten plastic at a time to build the 3D print. Looks like it's almost done with the infill. So this robot is heavy duty. It's overkill for 3D printing, but it's nice because you can remove the printer head by unscrewing the clamp and place a drill or whatever tool you want to do any kind of CNC work. All these parts here, the ball screw and these rails and these aluminum pieces, these are from McMaster-Carr, which is an industrial supply company. It's probably my favorite place to go shopping. The stepper motors and the drivers and most of the electronics is from a company called OMCStepperMotorsOnline.com. The printer head, which is just made from a stepper motor, an extruder, and a hot end. All of that is from matterhackers.com. It's a really good piece of hardware. It's a little pricey, but it's definitely worth it. So is the plastic. It's from Matterhackers. So, looks like it's almost done with the infill, and then we could watch it run the perimeter. The print bed is a little bit unique. Usually people use glass and they use a heater, but in my case I found a piece of wood with this painter's tape over it works just fine. The first layer stuck right to it, and it's I haven't had a problem with that at all. The print bed is actually adjustable right here, so you can make it all level. And it's working out pretty well. So this little fan right here is actually to keep the it's running the perimeter. Let's watch that. This little piece of metal right here, that's the heater block. It gets hot enough to melt the plastic, but up here it has a heat sink that this fan keeps cool. So there's a sharp temperature difference there where the plastic gets fed in from the extruder and it gets melted and squirted out. It's hot enough to bond to the layers that are already there, and it makes the part pretty darn strong. There it goes. It's really fun to watch a 3D printer at work in person, especially when you built it from the ground up. It's working on that infill again. Oh, it actually looks like it's doing the top surface of the part. It's making it smoother so it's nice and pretty. The infill was a honeycomb pattern that makes it lighter weight and it uses less plastic. I'm going to go ahead and stop the video here because I don't want it to be too long. Yet again, I'm Julian Erickson, and I really like to tinker with this sort of thing. And I hope to make a lot of 3D prints over the lifetime of this robot because it's really sturdy.